Hello, everyone. Welcome to the very first video in this review series for the upcoming AP Stats exam. The goal with all of these videos is going to be essentially just to give you a very basic idea of what to expect for the AP exam and each of these little subtopics, as well as if there is any specific things to go through as far as exam strategy or question wording or anything else specifically related to the exam itself. That's what I'm going to try to cover. Um, Otherwise, let's get right into it. So the first topic we're going to look at today is the very first subtopic from Unit 1, which is just what is a variable? Now, one thing that's really, really important with this topic is that typically it is not tested directly on the AP exam. Rather, it's a set of vocabulary that you guys need to know in order to make sure you succeed. So if you don't know the difference between a continuous and a discrete variable, or a quantitative and a categorical variable, they're not going to ask you a question about that specifically. But they will use that vocabulary in the wording of the question. And so if you don't know it, that's when things can get difficult. So one way I like to describe it, this definition and the definitions on this page come directly from College Board. So they define a variable as any characteristic that changes from one individual to another. Great. So think about things like height, right? Things like height, things like eye color, etc., etc. Shoe size, any other example, you name it. They specifically go into things that can be measured or counted. Now, that is the way that I like to think about things personally. If I can measure it, like your height or your weight or your shoe size or the length of your arms, or insert any other example here, or if I can count it, the number of siblings you have, the number of homes that you've lived in, the number of cars that you own, the number of friends that you have, things along those lines. Another example of a variable. This is where statistics differs from your other math classes, because in every other math class you've taken, a variable is X, something that changes constantly. However, if we look at a variable as a height, I'm done growing, right? And many people taking this class also are done growing. My height isn't going to change for a very long time. And so in this particular case, a variable is just something that differs between individuals. Now we have two types, or two big categories here, of variables, and that's categorical versus quantitative. I apologize for my sound bar. Again, categorical variables, the other name for this is qualitative. That's another word that you may see depending on the website that you're looking at for review or other textbooks, etc. But again, the idea is this is not represented by a number. It's just something that puts you within a category. Again, an example like eye color, hair color, favorite sports team, favorite restaurant to eat at, etc. Quantitative variables are things that are numerical. Your height, your weight, the number of siblings you have, etc. One thing to be careful about, right, here is just because it's a number doesn't mean it's quantitative. The reason why I say that is that if you think of something like a zip code is numerical, but it just tells you the town or city that someone lives in, or wherever you're mailing a package to, or where something is coming from. Same thing with an area code or a telephone number. It's just putting you into a category, right? For example, if you live in Massachusetts, you may have the area code of 978, or if you live in New York, you may have the area code of 845 or 914. Those are numbers, right? But they don't actually represent any sort of quantity. They just represent an area, right? If you're a Morgan Wallen fan, number 865 shows up a lot in his songs. It's the area code for the part of Tennessee that he is from, right? So again, very, very important to know that just because something shows up as a number does not make it quantitative. And how do you know? The way I look at it is, does this thing, like, obviously, if it's something like can't speak here, eye color or hair color, very obvious. But if really the hard part's going to be to discern, does this number represent an actual quantity of something, or does it just tell me an area of the country, right? Something like a zip code or an area code. Now, the other thing that's important here, discrete versus continuous. Discrete just means that there's a finite number of values, and continuous means there's an infinite number of values. The way people like to think about this essentially is that discrete means there's no decimals. But I'm not a big fan of that, because something like shoe size, you can have decimals in shoe size, 9, 9.5, 10, so forth. But for shoe size, there is a finite number of possible values. However, when you look at something like height, I can measure your height down to the bazillionth of an inch. There is an infinite number of values there. Now, how do we actually represent things? With categorical data, it's pretty simple. We either represent it with bar graphs or we represent it with tables. So something like you see here. Remember, the biggest difference between a bar graph and a histogram is the type of data used on the x-axis. All right, so you can see here, I just picked a random bar graph off of the internet, your favorite type of movie. And here, right, when we're looking at this table of people, it's eye color versus hair color. Again, both categorical or qualitative variables. Just how many people are blonde and have green eyes, that's just 4 total people. This is really the only 2 ways that we represent categorical or qualitative data. When we get on to quantitative data, we've got 4 different ways, and I have a totally separate video about this coming up later on, about how do we know which one to make, when we make one of these, how do we describe it, etc. So this is just kind of the basic overview. We use a histogram, a box plot, a stem plot, or a dot plot. Now on here, I only have an example of a histogram, which you can see, and a box plot. That's it. Stem plots and dot plots look very similar to histograms, and obviously we'll go over those in detail in another video. But notice here with a histogram, your x-axis is now quantitative, right? If I zoom in here, this x-axis is now the dollar amounts for a particular item, whatever that may be. And the y-axis is the frequency still. The other difference is that in a histogram, the bars actually are adjacent and touch each other, whereas in a bar graph, there's space. A box plot, completely different story, and we'll talk about how to make a box plot in another one, but it's made using something called the 5-number summary, which is why you see those 2 dots and then the rectangle in the middle that has 3 vertical sides. Yeah, these are the 4 major ways that we represent quantitative data. Like I said, in 2 videos or so, there will be a description of how do you do this, why do we do this, when should I use each one. But for now, again, just big picture overview type stuff. And so, in summary here, you've got 2 different variable types. You've got quantitative and categorical. Within quantitative, you also have discrete versus continuous. And then depending on which type of variable you have, that will dictate what type of data display you end up using. If you have a categorical variable, you're going to end up with a table or a bar graph. If you have a quantitative variable, you have a lot more options. So I hope that was helpful, and I'll see you guys in the next one.